Welcome to Brain Vision.
Chapter 3, Problem 30 says use effective nuclear charge, shielding, and the end value of the valence orbital to explain the trend in atomic radius as we move across a period in a periodic table. So, first things first, the effective nuclear charge is denoted by this equation. Z effective is going to be equal to Z minus S, where Z here is the charge of the nucleus and S is the number of shielding electrons. So since we're doing this across the periodic table, let's go ahead and draw several elements as we move across the periodic table. Let's do period 2. In period 2, we have lithium, beryllium, we have boron, and then we have carbon. Of course, there's nitrogen and oxygen as well, but this trend is going to continue, so we'll just assume what we're saying with the following 4 will continue throughout the period. So with lithium, there is a 3 positive charge. Because there's atomic number, there are 3 protons in its nucleus. The number of electrons in the first energy level is 2. Because this is period 2, the end value is 2, so there are 2 energy levels. First energy level, like I said, has 2 electrons. The second energy level will have 1 and a neutral atom, giving a total of 3 electrons and 3 positive charges. For beryllium, there's 4 protons in the nucleus. In the first energy level, there are also 2. Being the same period, it still has 2 energy levels. So in the second energy level, we have 1 electron here and 2 electrons, another electron there, giving a total of 4 electrons, 2 in the outer energy level. With boron, there's a 5 protons in the nucleus with a +5 charge. First energy level has 2 electrons. Second energy level has 1 additional, giving us a total of 3. And then in carbon, there's 6 protons in this nucleus. First energy level has 2 electrons. Second energy level has 4. Again, as you notice, the end value, meaning the energy level, is 2 for each one because we're working with period 2. So let's find Z effective for each of these. Z effective is going to be equal to Z, which is the charge of the nucleus. For lithium, that is 3. For beryllium, that is 4. For boron, that is 5. And for carbon, that is 6. And again, it's all positive because charge of the nucleus is 6 for the 6 protons or 5 for the 5 protons, etc. Then let's look at the concept of shielding. Shielding looks at the ability of an outer electron, I'm going to circle it in red, to feel the charge of this nucleus. Outer electrons can feel the charge. However, when there are inner electrons or core electrons, they can block this outer electron from feeling this charge. And so the outer electron feels less than the +3 charge. So this outer electron is blocked by 2 electrons. So there are 2 electrons that are shielding this outer electron from the positive nucleus. So therefore, we subtract 2. From here with beryllium, there are 2 outer electrons. They are each being blocked by 2 inner or core electrons from feeling the net positive charge of the nucleus. Now the outer electrons do not shield one another. It is the inner electrons that cause these electrons to be shielded. So this negative is blocked by 2 electrons inside that are shielding it. There are 3 outer electrons for boron. I'll only circle 1 for the sake of the explanation. This outer electron is blocked by 2 electrons that are shielding it from reaching the positive protons in the nucleus. So let's fix that, subtract 2 as well. And then with carbon, this outer electron is also blocked by the 2 inner electrons, which are shielding it from filling a total of the 6 protons in the center. So we subtract 2 for the shielding electrons. So when we find the net effective charge for lithium, we get that it's positive. That means this electron feels 3 positives, but there's 2 negatives blocking it, so the net it feels is +1. The net for beryllium becomes +2. The net for boron becomes +3. And the net for carbon becomes +4. So as this electron, once again, tries to feel this positive charge, it is shielded by electrons on the inside, the core electrons, causing the net or effective nuclear charge to be less than the actual nuclear charge of the nucleus. So this influences the radius or the size of the atom. As you notice, as you go across a period, the nucleus effective nuclear charge increases. This means the charge here gets stronger and stronger and stronger. And as we know, opposite charges attract one another. The negative of these electrons are attracted to the positive inside. The stronger this positive gets, the more this negative electron is attracted. The weaker the positive is, the less this negative electron is attracted. So it's still attracted, but not to the greater extent. As this attraction increases and this positive charge gets larger, this negative is pulled in even closer, making the atom smaller and therefore making the radius smaller. So as we move across the periodic table, the net nuclear charge of this nucleus increases, pulling in the electron a little bit closer and making the atomic radius smaller.